Hi everyone, I just wanted to talk about the new chapter, chapter 3, which is on indices and surds. Now, the first chapter 3a is about irrational numbers and surds. Now, you may or may not have heard of this word before, surd. It's a funny word. They're numbers that use the square root or radical sign. You may hear it. It's actually the technical term for it is radical. Surds are what's called irrational numbers. So that means if they are expressed as decimals, their decimals form an infinitely non-recurring pattern. So a good example of an irrational number, you just look down the bottom here, is pi. So pi is a famous one. Everyone knows that the digits after the 3 in pi go on forever and ever without a pattern. Now, surds are the same sort of thing. Now, I just wanted to give you a couple of examples of numbers that are classed as surds. So just looking at, let's have a look at root. Square root of 2, the square root of 3, and the square root of 4. Okay, so there's three numbers with the square root over them. The first one, so the best way to do this is to get on your calculator and work these out, because it is quite difficult to calculate a square root by hand. Now, if you do this on your calculator, you get this number 1.4142, and it goes on forever and ever. Okay, so that means that's called a surd, all right, or an irrational number. Root 3 is the same, so if I do the square root of 3, I get so that equals 1.7320 forever and ever. My calculator only goes to 10 decimal or 9 decimal places, but it would go on forever and ever without repeating. Now, square root of 4 is a little bit different. So even though it does look like a surd, the square root of 4 is actually has a whole number solution. So the square root of 4, you should probably know, is equal to 2. Now, square root of 4 is not a surd because it can be simplified. Okay, so so I'm just going to write this down as a rule. Any square number with a square root sign is not a surd. Okay, so that's an important exception to the rule. Okay, so not everything with a square root sign is a surd. Some of them can be simplified. So another example would be square root of 9, which is 3. Now, the technical definition of an irrational number are numbers that cannot be expressed as a fraction, a divided by b, where a and b integers, and b is not equal to 0. So all that means is you can't express. So for example, let's have a look up here. You can express square root of 2 as a fraction where the top and the bottom are both whole numbers. Okay. However, you can express this one as a fraction where a and b are whole numbers. 2 over 1 is a really good example. 4 over 2 is another example where those both equal 2. Okay, so they fulfill that criteria. Now, pi is an example of an irrational number that is not a surd. Okay, pi is it has an infinitely non-recurring decimal, but no square root signs. Now, you'll learn a bit more about what pi is or how it's calculated when you get into a bit higher level maths. Okay, so rational numbers, so the opposite of a irrational number is a rational number. Okay, so you have integers and fractions. So they're the other numbers, integers and fractions, together with irrational numbers, surds, and numbers like pi. They're all called real numbers. Okay, and they can all be placed on a number line. And I'll show you how to do this in a second. Okay, incidentally, it's not in this chapter, but I don't think so. But numbers like pi, and so pi, and there's another number, a famous number called Euler's constant, or Euler's number, which is represented by E, which you might learn about next year, are called transcendental numbers. Okay, and transcendental numbers, I like to think of them as constructed numbers, and they're constructed by sequences and series and that sort of thing, which you'll learn about later. all you need to know now is that they are irrational. Okay, so let's have a look at a question on some of these definitions. So express each number as a decimal and decide if they are rational or irrational. Then locate all the numbers on the same number line. Okay, so in this case we've got the negative square root of 3. Now I'll just refer back up to the question we did before. Square root of 3, if you do that on your calculator, and I think you're actually allowed to do these on your calculator, ends up being 1.7325, etc., forever and ever. Now, this is a negative version of that, so it's an irrational number. So you're right, it's an irrational number. Okay, it's a surd. It just happens to be a negative surd. Okay, so negative surds are also surds as well. So we'll do the number line in a minute. We'll come back to that, and we'll go to 137%. Okay, kind of a strange question, but another way to think about it is, can you express that as a fraction of whole numbers? And the answer is yes, because 137% is simply 137 divided by 100. Okay, so that's a fraction where the two numbers are integers. That is a rational number. Okay, now 3/7. This is an interesting one, because if you put in your calculator 3 divided by 7, which is what it's asking you to do, okay, you get this. If your calculator's got enough decimal places, you'll see that that's equal to 0.428571428. Okay, and you might look at that and go, well, that's not. There's no pattern there. But what you'll find, if you keep going, my calculator only has 10 decimal places, or 9 in this case. It would go on, it would repeat this pattern. So you'd actually write it with a line above there, if you remember how to draw these. That is a rational number. Okay, and you can almost pick it right from the start, because that is a fraction here. This is a fraction of two whole integers. Okay, so that by definition that is a rational number. Okay, just coming to the number line. Okay, so one of the questions in here is to draw a number line. Let me see if I can get a line. Here's my number line. Oh, big yellow number line. Hope I can change that. No. Hang on, I'll get rid of that. Let's do that again. Okay, so here's my number line. Okay, so let's put 0 in the middle here. Okay, over to the right here is all my positive numbers, and all over here is my left. So 137 over, negative square root of 3. If you remember, it's actually going to be the negative version of this here. Okay, so negative 1.73. So if that's 1 or negative 1, and that's negative 2, negative root 3 is going to be here somewhere at approximately negative 1.73. Okay, the second one, 137 over 100. If you were to write that as a mixed number, you'd actually get 1 and 37 over 100. Okay, so it's nearly positive 2. Actually, sorry, I'll put it in here. Positive 1, 2, and I'm going to put it in red. So 1 and 37 hundredths is just less than 1 and a half, so it's over here somewhere. Okay, so you can write 137 over 100 there. Okay, and the last one is 3/7. 0.428 something something something. It's about here, so just before point half. Okay, so you can write 3/7 there. Okay, so that's how you decide whether these are rational or irrational. Have a look at the questions in the book and have a go at that.